question number 4, they say that a particle P moves in a straight line. It starts from rest at a point O on the line, and at time t seconds after leaving O, it has an acceleration a meters per second, where a is equals to 6t minus 18. Find the distance p moves before it comes to instantaneous rest. So for acceleration, we have 6t minus 18, which basically means that there is variable acceleration, so it keeps changing. Hence, we will also have variable distance as well as velocity. So we know that whenever we integrate acceleration, we get velocity, and when we integrate velocity, we get displacement. And in the case that the velocity does not change signs, as in from negative to positive or positive to negative, the displacement is also always equal to the distance. So first we can do these integrations to find out the equations for both the velocity and the displacement. So first let's integrate the acceleration. So we get the velocity is equals to 6t squared divided by 2 minus 18t plus c. So this is equals to 3t squared minus 18t, and this c will be equal to 0 since this is the y-intercept, and since the reference point is this point O where it starts from, we can say that when t is equals to 0, both the velocity and displacement should also be equal to 0. So if we substitute t is equal to 0, we will find that we will get velocity is also equal to 0. So this arbitrary constant will also be equal to 0. So this is the equation for velocity. Moving on, if we integrate velocity, we will find the equation for displacement, and that will be 3t cubed divided by 3 minus 18t squared divided by 2 plus c. Again, this arbitrary constant is 0, since when t is equals to 0, displacement is also equal to 0. So we get the formula for displacement equals to t cubed minus 9t squared, and that is the equation for displacement. We need to find out the time when the particle is at instantaneous rest. So what we do is that we equate this equation equal to 0, the velocity equation, this over here. So if we simplify this velocity formula, we can get t squared minus 6t, since we divide 3, and simplifying it further, we can write t is equals to t minus 6, and equating velocity equal to 0, we can find that t is equals to 0 and t is equals to 6. So these are the two times when the velocity is equals to 0. Now let's make sure that the particle does not change directions, since in that case distance and displacement will be two different things. So we know that the equation for the velocity we found out as 3t squared minus 18t, and that the velocity is equals to 0 when t is equals to 0 and t is equals to 6. And this is a quadratic equation, so it will probably look like this. So when we draw a velocity time graph, we can see that this is velocity and this is time. So this is, let's say this is t is equals to 0 and this is t is equals to 6. So let's take any value between t is equal to 0 and t is equal to 6. Let's say 3. T is equals to 3. We will find that velocity is equal to negative 27, meaning that it will be somewhere over here. So this shows that the particle starts from rest, so it is velocity is equals to 0, and then it gets negative, and then it gets more negative, and then it comes to rest when t is equals to 6. What this negative velocity means is that from the reference point O, let's say that we take the positive direction as the right side and the negative direction as the left side. What it means is that it moves in the opposite direction. So let's say it moves left. What this also indicates is that it keeps moving in a straight line, so distance will be equal to displacement in this case. So what we can do is that we can substitute this t is equals to 0 and t is equals to 6 in the displacement formula directly, and that will equal to distance traveled. So when we put in t is equals to 0, we will find that displacement is also equals to 0. and then when we put in t is equals to 6, we get the displacement equals to negative 108. Again, it means the same thing, that instead of moving rightwards, the particle just moves leftwards as indicated by this velocity time graph that we drew. So now we have the distance traveled between the times when the particle is at instantaneous rest, which is 108 meters. So with that, we're done with question number 4.